Have you ever wondered how electrical devices manage power effectively? Meet the inductor, a tiny component with a huge impact. An inductor is a passive electrical device, typically made of coiled copper wire. Its main job? To oppose changes in current. It does this by storing energy in a magnetic field, following the principles of Faraday and Lenz. An inductor is represented by a coil symbol and denoted by L in circuits. The unit of inductance is Henry, H. Let's break this concept down into simple steps. First, when current flows through the inductor, it builds a magnetic field. This field produces back EMF, which is an opposing voltage. Because of this, the current rises gradually instead of suddenly. Now, let's consider what happens when the current supply turns off. The magnetic field collapses, releasing the stored energy. This can create a high voltage spike, an effect that's crucial in many electrical systems. That's why we often use flyback diodes in circuits with relays and motors. So how do we measure the voltage across an inductor? The formula is simple. V equals L asterisk D, dt. This equation tells us how voltage changes based on the inductance and the rate of current change. Inductors also play a significant role in AC circuits. Their opposition to current, called inductive reactance, is determined by the formula XL equals 2 pi FL. Here, frequency greatly influences how much opposition the inductor provides. Now, let's see practical applications. In phone chargers and SMPS power supplies, inductors temporarily store energy when the device is on. They release this energy when it's off, allowing for efficient voltage conversion and smoothing the current flow. Think of inductors as short-term energy buffers. They quickly absorb or release energy to stabilize power flow, ensuring devices run smoothly. In electric motors, inductors create controlled magnetic fields within the stator windings. These fields interact with the rotor, producing torque. Back EMF comes into play here too, regulating the current and preventing sudden surges. Now, the confusion arises. What is this back EMF? Back EMF is the voltage produced in a coil motor that opposes the change in current that flows through the coil. Inductors come in various types. Air core inductors are used in RF circuits, while iron core inductors are common in motors and transformers. Ferrite core inductors suit chargers and high-frequency circuits, and chokes help with noise suppression. Representation. Symbols of these inductors are as shown in summary. Inductors are vital in chargers, motors, power supplies, filters, and communication systems. They enable efficient energy transfer, smooth current flow, and reliable electromagnetic control. Now that you understand inductors, think about how they influence your everyday technology. Want to learn more about electrical components? Subscribe to our channel for more insights.